Okay, let's unpack this. The world of AI is moving at light speed, and today we're bringing you the freshest, most impactful developments from just the last 24 hours.
It really is. It feels like you blink and there's something new.
Totally. And keeping up can feel like a full-time job, honestly.
It absolutely can. What's particularly striking right now, I think, is how these seemingly disparate announcements and breakthroughs aren't just isolated events.
Right.
They actually connect in fascinating ways, showing us precisely where the frontier of AI is pushing next.
Oh, okay.
Our mission today is to distill the core insights from Google's latest AI agents, some truly groundbreaking models, and even a new, crucial way to think about how AI understands and processes information.
Kind of putting the puzzle pieces together.
Exactly. We want to put all these pieces together for you
Yeah.
so you walk away truly well-informed.
Absolutely. So we're diving into Google's new Gemini CLI agent first.
Yep.
Then we're taking a deep look at the surprisingly profound world of context engineering, a skill you'll definitely want to know about.
Oh, for sure. Crucial stuff.
From there, we'll explore a major leap forward in DNA analysis with Google Alpha Genome.
Very cool tech there.
Get the latest on compact yet incredibly powerful models like Gen Nano 128K and Mistral Small 3.2.
Yeah, the little guy's punching hard.
And we'll even check in on how AI is performing on what some are calling humanity's last exam.
Intriguing name, right?
It really is. So prepare for some serious aha moments, hopefully.
Ah.
Kicking things off, let's talk about Google's new Gemini CLI agent.
Okay.
This is an open source AI agent designed for your terminal right in the command line.
Mm-hmm.
And what immediately caught everyone's eye was their free tier. We're talking 1,000 requests per day.
Per day. Wow.
Yeah, at a rate of 60 requests per minute. That sounds incredibly generous on paper almost. Comically so.
Like suspiciously generous?
Kind of. Some folks were even joking online that maybe a dyslexic intern at Google mixed up 10 requests a week with 1,000 a day.
Huh. You do wonder.
It's certainly an aggressive entry into the market. What was your initial reaction to that kind of offering?
Well, it's certainly a bold move, isn't it? And if we connect this to the bigger picture, strategically, it positions Gemini CLI as a direct competitor to tools like, say, Claude Code.
Right, the coding assistants.
Exactly. This is setting up what many are calling a battle royale of CLI coding agents, all vying for developers' attention right there in the terminal.
Makes sense.
And technically, it boasts a massive 1 million token context window.
1 million in a CLI tool.
Yep. Which, for a terminal-based tool, is quite significant for handling complex, multi-step tasks without, losing its place. That context window alone signals Google's ambition here.
That large context window does sound amazing for developers dealing with sprawling code bases or long sessions. But here's where it gets, well, maybe a bit messy.
Uh-oh. The catch?
Maybe. While that generous free tier is eye-catching, there's a nuance that quickly emerged. Google does collect prompts, code, outputs, edits, and feedback for model improvement.
Ah, the data collection aspect.
Exactly. Now, they do state you can opt out and that this data is separated from your Google account. But it's, an important privacy consideration for users.
Always is.
And beyond that, despite the fanfare, early users have reported a pretty bumpy launch.
Oh, really? Like what?
Well, we've seen complaints of it being buggy, super slow, freezing up.
Okay. Typical early release stuff, maybe.
Maybe, yeah. And even failing basic installations. In fact, there was even a noted brief disappearance of the official announcement and GitHub repository.
Oh, wow, they pulled it back.
Briefly, it seems, hinting at some early release issues that Google is clearly, scrambling to resolve.
Right, that kind of initial friction isn't uncommon with ambitious new tools, is it? But it actually raises an important question.
Which is?
How these agents are supposed to understand and process all that information within those massive context windows, especially when dealing with complex real-world tasks.
Yeah, how do they use that million tokens effectively?
Precisely. The entire conversation around Gemini's large context window directly ties into a term gaining significant traction in the AI community: context engineering.
Context engineering. Okay, heard that buzzing around.
You probably have. It's a concept that Walden from Cognition first coined, I believe, and Shopify CEO Tobi Lutke has championed it as a must-know skill set in AI engineering.
A must-know skill set.
And for very good reason.
Yeah.
It's fundamentally shifting how we think about interacting with and building upon large language models.
Okay, let's unpack this context engineering then, because it sounds like it's far more than just, writing a clever prompt. What exactly does it involve?
You're absolutely right. It's exponentially more complex than simple prompt engineering. Think of context engineering as the delicate art and science.
Art and science.
Of filling an LLM's context window with just the right information at the right time for the model to successfully perform the next step of a task.
So curating the input.
Meticulously curating and managing everything that goes into that window. This includes crafting incredibly precise task descriptions, providing well-chosen few-shot examples to guide the model's behavior, strategically using Retrieval-Augmented Generation, or RG, to dynamically pull in relevant external data,
RD, right.
efficiently connecting to various tools and APIs, intelligently managing the conversation's state and history, and even proactively compacting information to maximize efficiency within that often limited context window.
Wow, okay. That's a lot more involved than I thought.
It really is.
So it sounds like if prompt engineering was giving a brilliant student a single instruction, context engineering is like setting up their entire study environment,
That's a great analogy.
complete with all the right textbooks, tools, and past examples. What makes it such a, you called it, non-trivial challenge?
Well, it's a science because getting it right involves truly meticulous packaging and managing of information for an LLM to perform a task optimally. Think of it this way. Too little information or the wrong kind, and the model simply won't perform well. Performance suffers.
Right, makes sense.
But equally, too much information or stuff that's too irrelevant, and not only do your costs go up significantly.
Because you're processing more tokens.
Exactly. But performance can actually decrease because the model gets overwhelmed or distracted by the noise.
Ah, okay. So more isn't always better.
Definitely not. It requires what some experts call an intuition around LLM psychology, sort of understanding how these models internally process and prioritize information.
LLM psychology. Interesting phrase.
And this skill is absolutely essential for building reliable, robust AI agents, especially for complex applications like voice agents needing to follow multi-step workflows.
Yeah, I can see that.
This is precisely why specialized tools like DSPy are gaining so much traction. They're essentially becoming the context engineering tools of choice because they help formalize and optimize this incredibly complex process.
So tools to help manage this complexity.
Exactly. This isn't just a new skill, it's kind of the bridge to building truly reliable, cost-efficient AI agents. It's transforming how we move from just a simple prompt to a production-ready AI solution.
And that makes perfect sense. It really highlights that the power of an LLM isn't just in its raw capabilities, but in how skillfully it's fed information.
Precisely. Garbage in, garbage out still applies.
Yeah.
In a much more complex way.
Right. Now, moving from the architecture of AI agents to the AI models themselves, we've seen some truly surprising developments in how much punch a smaller model can pack.
Oh yeah, this is fascinating stuff.
Let's talk about Jano 128K and Mistral Small 3.2. These aren't the largest models out there by far, but their performance is making serious waves.
Indeed. One thing that really grabbed my attention this week is Jano 128K. Get this, it's a mere 4 billion parameter model.
Only 4 billion, that's tiny compared to the giants.
Tiny. It's a Qwen 3 fine-tuned LLM. What stands out immediately is its super long 128K token context window.
128K on a 4B model. How?
Well, they've optimized it using something called yarn scaling.
Yarn scaling.
Yeah, it's essentially a clever method to extend a model's ability to handle longer sequences while hopefully maintaining performance.
Okay. And the results.
In their benchmarks, it achieved a simple QA score of 83.2, which is remarkably high.
How high are we talking?
It actually outperformed much larger models, including DeepSeek 671B, GPT-4o, and even Gemini 2.5 Pro.
Whoa, wait. Outperformed GPT-4o.
Under minimal prompting conditions, according to the report. Now, it's true there's some skepticism in the community
Okay, I was going to ask.
around its benchmarking methodology without a full public report yet. But if these reported performances hold up, it's a massive deal for the future of compact local models.
Huge. Imagine powerful AI running effectively on your phone or laptop.
Exactly. That's the dream, right?
That's a huge claim for a smaller model, though. And it makes me wonder, how are these smaller models suddenly achieving such impressive feats?
It's a combination of better architectures, smarter training data, and these fine-tuning techniques like the yarn scaling.
Right. And then there's Mistral Small 3.2, another fascinating development.
Yeah, Mistral Small 3.2. That's a 24 billion parameter LLM. So bigger than Nano, but still small compared to the top tier.
Still in the small category, relatively speaking.
Right. And user testing and community feedback suggest it's performing well above its size class.
Again.
Yeah, even reportedly outpacing much larger models like Llama 3.370B and Qwen 2.572B, particularly in tasks like writing and logical reasoning.
Interesting. So not just benchmarks, but actual user experience.
That's what people are reporting. Now, there were some initial technical hiccups.
Ah, like the Gemini agent?
Kind of. Issues with its tool calling and data outputs, kind of annoying bugs developers hit in early releases.
Sure.
But the community has already started producing fixes, which speaks to its rapid adoption and the interest around it.
That's a good sign.
And the anticipation for a potential Mistral Media model is now incredibly high, given this impressive performance-to-size ratio.
Yeah, if small is this good.
Exactly.
Yeah.
It genuinely makes you wonder, as you said, just how efficient these models can realistically get before we hit some fundamental computational limits.
That's a fascinating trajectory. It's like we're seeing miniaturization happen in AI, similar to what we saw with computer chips decades ago.
Feels a bit like that, yeah.
And this naturally leads us to consider, what can these increasingly powerful and efficient AI models be applied to next, especially outside the traditional text and code domains?
Good question.
This week, Google DeepMind and Google AI introduced AlphaGenome.
Ah, yes, AlphaGenome.
A new AI model designed to help scientists better understand DNA. What's the big picture here for biology?
AlphaGenome is genuinely a significant step into the biological frontier. It's not just processing DNA, it's fundamentally potentially reshaping biological discovery.
How so?
Well, this model can predict the impact of genetic mutations. And get this, it reads a staggering 1 million bases of DNA.
A million base pair.
Yeah, megabase. And it predicts biological function directly from the sequence alone. What's truly revolutionary, I think, is its architecture. It's a hybrid convolutional transformer architecture.
Hybrid. Okay, break that down.
Think of it like this. A convolutional network, a CNN, is great at spotting fine-grained local patterns, like recognizing individual letters or short words in text.
Okay.
While a transformer is excellent at understanding long-range relationships and context, like grasping the meaning of an entire paragraph or document.
Right, the attention mechanism.
Exactly. Combining them allows AlphaGenome to deliver predictions at single base pair resolution.
Single base pair, that's incredibly fine-grained.
It is. For regulatory properties across transcription, splicing, genetic variants, it effectively bridges the gap between understanding the big picture of a DNA sequence and the tiny crucial details that determine biological function.
So it's about seeing both the forest and the individual trees of the genetic codes simultaneously at an unprecedented scale and resolution. That's a perfect way to put it. What are the practical implications of something like AlphaGenome for scientific research right now? Is it changing experiments tomorrow?
Well, the real breakthrough here is its ability to process that full megabase while still providing those predictions at single base pair resolution. That unification is key. Now, it's important to be clear. Its predictive power isn't perfect. The R values, a measure of correlation, are around 0.8 to 0.85.
Which is good, but not perfect.
Right. It reflects the inherent biological complexity and the natural variability in living systems. It's not a diagnostic magic bullet that tells you definitively what a mutation will do in a person.
Okay, so manage expectations. It's not predicting diseases directly off the bat.
Not yet, no.
Yeah.
Instead, think of it as a pragmatic, powerful, basic science tool.
How does it help researchers then?
It empowers them to rapidly interpret statistical signals from massive genetic studies, like genome-wide association studies. It helps filter out noise.
Which there's a lot of in genetic data.
A huge amount. It helps prioritize which causal variants are most likely to be significant and significantly accelerate hypothesis generation for actual lab experiments.
So it guides the experimental work, makes it more efficient.
Precisely. It allows scientists to turn raw genetic data into actionable insights much, much faster. That's invaluable for driving new discoveries.
That's a massive acceleration for fundamental biological research. Okay, shifting gears one last time.
All right.
Finally, let's look at a fascinating barometer of AI progress. A benchmark aptly named Humanity's Last Exam.
That name.
I know, right? This tracks how AI models are performing on truly complex, open-ended tasks. And the graph shows a consistent upward trend from April 2024 to June 2025. Scores are generally ranging from 0% to 30%.
So nobody's acing it yet, not even
It's
close.
not even close. It sounds like a ridiculously tough test.
It is designed to be just that, pushing the absolute boundaries of what these models can do. What's fascinating here is that Moonshot AI's Kimi researcher
Kimi. Okay.
has achieved a record pass at one score of 26.9%.
27%, roughly. Highest so far.
Yep, and that's a notable jump from its initial 8.6%.
Wow. Big improvement. How to do it.
Well, this model strategy for tackling these complex problems is particularly revealing. It averages 23 reasoning steps.
23 steps.
Yeah, and explores over 200 URLs per task.
Whoa. So it's doing deep research and complex reasoning.
Exactly. It showcases a highly sophisticated multimodal approach to problem solving. And, major models like GPT-4o and Claude 3.5 Sonnet are also tracked on this exam, demonstrating consistent, albeit sometimes slower, improvements over time.
And it's also worth noting, I saw, that GPT-4o shows a significantly lower calibration error percentage compared to other top models on this benchmark.
Calibration error. Good point.
For you, the listener, that's a very desirable trait because it means the model is less overconfident when it's wrong.
Which is hugely important for trust,
Yeah,
right?
totally. It's a subtle but profoundly important indicator of a model's reliability and trustworthiness in complex, high-stakes scenarios. It's not just about getting the right answer, but knowing when you might be wrong.
Exactly. And this whole benchmark, this progress, raises an important question. What does it truly mean as AI models inch closer to passing what's provocatively called humanity's last exam?
Yeah, what does it mean?
Well, while no model is anywhere near a perfect score, the consistent progress we're seeing, combined with these sophisticated strategies like multi-step reasoning and extensive information exploration, it indicates a clear trajectory where AI is increasingly capable of tackling complex, open-ended knowledge tasks that once required significant human ingenuity.
Tasks we thought only humans could do.
Or at least required human-level reasoning. This isn't just about AI getting better at tests. It's a stark reminder, I think, that the very definition of intellectual mastery might be evolving. It encourages us to critically think about what this means for human roles in an increasingly AI-augmented world, and how our own capabilities might be augmented or maybe even redefined in the future.
A lot to think about there. So, wow, we've truly navigated the cutting edge of AI today.
Quite the journey in just the last 24 hours.
Right. From the ambition and maybe the stumbles of Google's new Gemini CLI
The bumpy
start to the increasingly crucial skill of context engineering.
Definitely one to watch.
We saw miniature models punching way above their weight with Gen Nano 128K and Mistral Small 3.2.
The rise of the efficient models.
Witnessed a leap in genetic understanding with AlphaGenome.
Biology meets AI in a big way.
And peered into AI's ongoing performance on humanity's last exam.
Charting the progress on those really hard problems. And if we connect all of this to the bigger picture, it really highlights that the advancements aren't just about raw computational power or simply building bigger models anymore.
Right, it's more nuanced.
It's profoundly about the strategic application of AI, whether that's in designing more reliable agents or, deciphering the intricate code of our very own DNA.
Strategy and application.
Yeah, it's a powerful reminder that truly understanding and leveraging AI isn't just about using the latest, shiniest model, but about understanding that intricate dance between intelligent input, sophisticated processing, and ultimately the desired outcome.
Exactly, the whole pipeline. So as these AI systems become more capable of navigating incredibly complex information and even tackling what's been called humanity's last exam, here's the thought I want to leave you with.
Okay.
How does your own approach to learning, to problem solving, and maybe even to critical thinking need to evolve to keep pace with these incredible, rapidly developing tools?
How do we adapt alongside them?
Yeah, something to ponder until our next deep dive.